Having Halloween decorations that comes to life is absolute fun. Unfortunately, there are significant constraints on what you can accomplish using store-bought props. Usually, each prop has its own switch or trigger to turn it on. These triggers, whether it is manual or sensor driven, aren't that durable and it might not work timely. In this video, you will see how to build a cheap and easy Digispark based system that can detect human motion and sets off our Halloween decoration. Now, let me show you the circuit first. We are an Altium designer. Altium is a PCB designer that can be used to create simple PCBs for our hobby projects or complex and multi-layer PCBs for industrial use. It's easy to create our own PCBs using Altium. If you are a DIY electronics enthusiast, you are gonna love it. Altium subscription includes Altium 365, which lets you design, share, and manufacture your projects in one place. Secure centralized cloud storage lets you share design and idea with teammates or clients. You can download and install the free trial version from the description down below. And if you are a student, you get a 6-month full license absolutely free. Don't miss out. Here, the input power is connected to a 7805 voltage regulator. 7805 is a 5-volt regulator which will convert input voltage between 7 to 32 volt to a steady 5-volt DC supply. That means you can connect an input voltage of anywhere between 7 to 32 volt. For this circuit, I prefer a 9-volt DC adapter. There are indicator LEDs across various points for easy troubleshooting. And this is where we connect our Digispark. Digispark is a lightweight microcontroller development board. Digispark comes with 6 GPIO pins, which includes I2C, SPI, and USB interface. It also has 3 PWM pins which can be used to control L293D motor drivers or servo motors. We can use Arduino IDE to program Digispark, but the way we upload the program is a little bit different than usual Arduino boards. I have explained how it is done in one of the previous videos, so if you want, you can check it out. Now, this is the sensor that will be triggering our action. A PIR sensor is a tiny circuit that can detect human moving around in front of it within a range of between 4 meters and 13 meters. There are mainly 3 pins to a PIR sensor: VCC, Vout, and ground. The output of the PIR sensor is connected to pin P0 of Digispark, which will act as a trigger, and pin 3 is connected to the relay, which will be connected to the actuator of the circuit that does the output operation. Here, you will also see a buzzer connected to pin P2 and an LDR connected to analog pin of Digispark if you want to play with light as well. Also, you will see a potentiometer here with which we can adjust the sensitivity of the LDR. Basically, that's all I needed for this project. If you are planning on making it, make sure you try it out on a breadboard, and once you get the output, you can use it as such or create your own PCB. I personally like PCBs. PCBs are neat, tidy, and helps to get rid of all nasty wires hanging around. Once the circuit was finished and tested, I designed a compact PCB using Altium where I can fix all the components neatly. Here, you can see that the routing is on both sides of the board, which means it's a dual layer PCB. I ordered my PCBs from PCB. PCB is a PCB manufacturer specializing in PCB prototyping, low volume production, and neat and tidy PCB assembly. To order your PCBs from PCB, go to PCB website and fill in the basic board details in the instant order form. And in the next screen, you can completely customize your PCB. You can change the thickness, change the solder mask color as well as the silk screen color, materials used, and you can customize it in every way possible. Corresponding prices will be updated here in real time. In PCB, you can even manufacture your PCBs with TG150 to 160 for the same price as that of TG130 to 140. This means your PCB will be able to operate in high temperature without any damage. In the next screen, you should be able to upload your Gerber file and submit it for a review. Once the review is completed, all that is left to do is add to cart, make the payment, and wait for your PCBs to arrive. Once you get all the components and the PCB, it's time for you to solder them together. Solder all the components onto the board and make sure to check the polarity of the components. After soldering, the PCB looks like this. We can now upload our code to Digispark. If you don't know how to set up Digispark, check out the video attached. Basically, what the code does is, it will read the value of pin 0, which is connected to the output of the PIR sensor. If the PIR sensor is sensing a movement or a person, it will turn the output from 0 to 1. If the value of PIR input is 1, then it will turn on the relay. When the relay is turned on, whatever connected to that circuit will also turn on. Once it is done, Connect the power adapter and you will see LED 1 will glow up. This means it is working. Now all you have to do is replace the switch of your Halloween prop with the output of the relay. That totally depends on your prop. In my case, I didn't remove the button here. Instead, I opened the bottom part of the prop and soldered the relay output to the pins where the switch was connected. Another thing to keep in mind is that you have to make sure that the voltage is almost as same as the potential difference between the pin of the switch or the sensor. Otherwise, you might burn the circuit. Once that is done, turn on the circuit, turn off the lights, place the whole setup in such a way that the PIR sensor faces the way, and let the people walk in. Have fun guys! Happy Halloween!